Before you stands a creature as tall as a two-story building. Its long neck stretches forward like a crane. Its four legs are solid pillars of bone, each wider than an adult human body, supporting a mass weighing tens of tons. When it moves, the ground sinks beneath its own weight, leaving footprints so vast that a car could park inside them. And yet this creature is still not the largest ever to walk the Earth. Across more than 4.5 billion years of Earth's history, there was a time when gigantism was not an exception, but a survival strategy. An era when nature relentlessly pushed the limits of life, creating beings whose scale defies human imagination. Even the infamous predator T-Rex would appear tiny when placed beside the dinosaurs we're about to explore today. Throughout the planet's history, many dinosaur species existed whose forms and sizes far exceeded all modern biological norms. Bodies longer than a football field, limb bones as thick as pillars, and masses so immense that scientists still struggle to understand how Earth could sustain them. If there is one dinosaur worthy of being called the ultimate symbol of size, it is Argentinosaurus. Argentinosaurus was not the first of the gigantic, long-necked dinosaurs to be discovered. But from the moment its first bones were unearthed in Argentina in the late 20th century, scientists knew they were facing something beyond every previous standard. A single back vertebra of Argentinosaurus rises to the chest of an adult human. Its thigh bone is longer than a person is tall. And as paleontologists began assembling the fossil fragments, the image that emerged was almost impossible to believe. Argentinosaurus may have reached a length of about 98 to 130 feet. Its estimated weight ranges from 70 to 100 tons, with some studies suggesting it may have been even greater. For comparison, a fully grown African elephant weighs about 6 tons. This means Argentinosaurus could weigh the equivalent of more than 10 elephants combined. And that is only its mass. Now imagine placing Argentinosaurus into the modern world. If it stood beside a long-distance bus, its body would stretch beyond several buses lined up end to end. If it crossed an American football field, its body length alone would occupy nearly the entire field. Its head would rise so high that it could reach the upper floors of an apartment building. But what makes Argentinosaurus truly astonishing is that it was not born at this size. It belonged to a group of gigantic herbivorous dinosaurs that dominated the southern hemisphere during the late Cretaceous. They grew from relatively small juveniles, facing countless dangers throughout the long journey to adulthood. So why did nature allow and even encourage a plant-eating animal to reach such colossal proportions? The answer lies in survival strategy. For Argentinosaurus, size itself was a weapon. A fully grown adult had almost no natural predators. Even the largest carnivorous dinosaurs of the time would have struggled to bring down a healthy individual. Thick layers of muscle, massive bones, and towering height turned Argentinosaurus into a living fortress. But maintaining such a body came at a high cost. Argentinosaurus needed to consume an enormous amount of food every day. Hundreds of pounds of vegetation. The ancient forests of South America at the time must have been extraordinarily rich, with dense plant life and a warm climate capable of sustaining entire populations of such giants. Every step taken by Argentinosaurus not only shook the ground, but also reshaped the ecosystem around it. Young trees were crushed, and natural pathways were carved simply by its movement from one place to another. Its presence transformed the landscape, much like how herds of elephants today can alter entire savannas. Ironically, despite its immense size, Argentinosaurus is one of the dinosaurs we know relatively little about. No complete skeleton has ever been found. Most of our understanding comes from scattered bones compared with those of closely related species. This makes Argentinosaurus both a symbol of gigantism and a reminder of the vast gaps in human knowledge of Earth's deep past. We know it existed. We know it was enormous. But its exact appearance, social behavior, and daily life remain open questions. And that leads to an intriguing truth. Argentinosaurus may be among the largest dinosaurs ever to live, but it was not the only one to reach such almost unimaginable size. In other regions, under different conditions, nature repeated this experiment many times. Some species were discovered later, with more complete fossils, forcing scientists to ask again. Was Argentinosaurus truly the greatest giant of them all? If Argentinosaurus is the symbol of gigantism in scientific imagination, then Patagotitan is the physical evidence that makes that gigantism concrete and undeniable. Patagotitan was discovered in Patagonia, southern Argentina, within rock layers dated to around 100 million years ago. According to some estimates, Patagotitan's body mass was about 10% greater than that of Argentinosaurus. Patagotitan belonged to the Titanosaur group. Its body weight was comparable to that of a modern space shuttle. Let us begin with the most immediately striking feature, the limb skeleton. The thigh bone of Patagotitan had a circumference so vast that an adult human could not wrap their arms around it. This was not a slender, elongated bone like those of many other long-necked dinosaurs, but a thick, dense mass resembling a pillar of stone. This reveals that Patagotitan was not only long, but extraordinarily heavy, with its entire body engineered to distribute weight across 4 limbs as efficiently as possible. The torso of Patagotitan was a colossal mass of muscle. Its rib cage was wide and deep, providing space for a complex respiratory system and massive internal organs. Its vertebrae were hollow on the inside to reduce overall weight, yet the outer structure was exceptionally strong, capable of supporting a body weighing tens of tons. The neck of Patagotitan was long, but not delicate. It was a chain of large, thick vertebrae, with tendons and muscles that allowed the head to be held at various heights. Unlike the softly curved necks often depicted in older illustrations, the neck of Patagotitan resembled a crane. Its head, by contrast, was relatively small compared to its body. This is a common trait among gigantic herbivorous dinosaurs. A smaller head reduced weight at the front, while allowing the long neck to reach distant food sources without moving the entire body. The jaws of Patagotitan were not designed for chewing. Instead, it had peg-like teeth suited for stripping leaves, tearing branches, and swallowing them whole. For a long time, science struggled to understand why and how a creature like this could grow to such terrifying size. But recent research appears to have found an answer. These were gigantic animals, but extremely slow. For creatures of this scale, simply standing up and moving was already a challenge. However, such size is believed to have suited the era. Experts suggest that Patagonia, 100 million years ago, was a landscape rich in plant life. Flowers and grasses exploded in growth, rising tall and abundant, so herbivorous dinosaurs hardly needed to search for food. What they had was a continuous buffet of vegetation from morning to night, and the dinosaurs simply grew larger and larger. And the larger the body became, the lower the risk of attack from carnivorous dinosaurs. 100 million years ago was the age of the fearsome T-Rex, but in terms of sheer size, they were insignificant by comparison. Overall, Patagotitan appears like a creature built to survive in a world where size was the ultimate advantage. Not agile, not flexible, but resilient, stable, and almost impossible to knock down. It was the remarkable completeness of the Patagotitan skeleton that allowed scientists to recalibrate many earlier estimates of Argentinosaurus and other titanosaurs. However, Patagotitan was still not the final peak of ancient Earth's gigantism. The name Dreadnoughtus comes from the term used for massive armored battleships of the 20th century, war machines designed to fear no enemy. And in the world of dinosaurs, the name is entirely fitting. Dreadnoughtus lived around 77 million years ago, also in South America. In 2014, a nearly intact fossil skeleton of Dreadnoughtus was discovered in southern Argentina. Remarkably, the skeleton was found in exceptional condition, with about 70% of it preserved, a rarity for dinosaurs of such enormous size. Paleontologists analyzing this extraordinarily rare fossil estimate that it weighed around 40 tons and measured about 85 feet in length. This makes it one of the largest creatures ever to walk the land. In form, Dreadnoughtus resembled a typical titanosaur, but with subtle differences, suggesting it may have been one of the most mature individuals ever found. The limb bones of Dreadnoughtus were immensely massive. The ratio between their length and thickness shows they were built not only to support weight, but to withstand tremendous forces during movement. Each step taken by Dreadnoughtus exerted enormous pressure on the ground, and its skeleton had to endure this strain for decades. The torso of Dreadnoughtus was even more robust than that of Patagotitan. The large dorsal vertebrae, with broad muscle attachment surfaces, indicate a highly developed muscular system. This suggests that Dreadnoughtus was not a sluggish animal, but could move relatively quickly for its size. The neck of Dreadnoughtus was slightly shorter than that of some other titanosaurs, but in return it was thick and exceptionally sturdy. This helped stabilize the head while feeding, and may have played a role in social behaviors such as size display or territorial disputes. The tail of Dreadnoughtus was an elongated mass of muscle, acting as a counterbalance to the front of the body. Viewed as a whole, its body resembled a mechanically perfect structure, where every part contributed to stabilizing an enormous mass. What truly sets Dreadnoughtus apart are signs that the individual discovered had not yet fully matured. If that is true, it means Dreadnoughtus could have grown even larger had it continued to live. That thought forces scientists to pause and reflect. A creature already weighing tens of tons, stretching beyond 80 feet, and yet still not at its maximum size. In today's natural world, that idea borders on the unimaginable. In another branch of dinosaur evolutionary history, gigantism took on an entirely different form, not through mass, but through length. And to understand that, we must encounter a creature whose body stretched so far it nearly shattered every limit of form. If Patagotitan and Dreadnoughtus overwhelm us with their sheer weight, the next creature astonishes in a different way. Dinosaurs whose bodies seem to extend almost endlessly. For many people, the image of a long-necked dinosaur with a sweeping tail trailing along the ground is the default vision of prehistory. And in most cases, that image is Diplodocus. Diplodocus lived during the late Jurassic, around 150 million years ago, long before the gigantic titanosaurs of the Cretaceous. It was not the heaviest nor the tallest, but it remains one of the most recognizable and extensively studied dinosaur forms ever discovered. The body of Diplodocus measured roughly 100 to more than 108 feet in length, yet most of that length did not come from the torso, but from the neck and especially the tail. The tail alone accounted for more than half of the total body length. It possessed a unique body structure, with paired bones along the underside of the tail that enhanced strength and mobility. The tail vertebrae began large and robust, then gradually became smaller and longer toward the tip. forming a structure like a colossal biological whip. For decades, scientists believed this tail served simply as a counterbalance to the long neck at the front. But more recent research suggests that Diplodocus may have used its tail as a defensive tool, possibly delivering strikes at extremely high speeds. Imagine a creature nearly 110 feet long, capable of snapping its tail behind it like a gigantic cord. That movement alone would have been enough to keep any predator at a distance. In posture, Diplodocus stood relatively low compared to the Titanosaurs. The front limbs were shorter than the hind limbs, giving the back a slight downward slope. This created a distinctive stance, both stable and more agile than the heavy giants of the Cretaceous. It was this balance between length, weight, and lightweight structure that made Diplodocus one of the most successful dinosaurs of its time. And that is why Diplodocus fossils are abundant, appearing in most major natural history museums across the United States and Europe. Supersaurus is not a dinosaur widely known in popular culture. It rarely appears in films or books. Yet within paleontology, its name is spoken with particular caution, because Supersaurus may have been the longest dinosaur ever to exist. Estimates suggest Supersaurus may have reached lengths of about 128 to 138 feet, with some studies pushing that figure as high as 164 feet. Notably, Supersaurus was not especially heavy compared to the gigantic Titanosaurs. Its enormity came almost entirely from its shape. The neck of Supersaurus was extraordinarily long, with large vertebrae optimized to reduce weight. Each vertebra resembled a hollow framework, where strength was retained at the surface, while mass was reduced to the absolute minimum. The torso of Supersaurus was not as bulky as that of Patagotitan or Dreadnoughtus. Instead, it was elongated and narrower, like a biological bridge connecting neck and tail. This allowed the entire body to stretch across a vast area, reducing pressure on any single point of contact with the ground. The tail of Supersaurus, like that of Diplodocus but on an even greater scale, extended behind it as an almost endless continuation of the body. Viewed as a whole, Supersaurus did not resemble a typical animal, but rather a moving segment of landscape. Supersaurus represents the pinnacle of an extreme evolutionary pathway. Instead of becoming heavier, it became longer. Instead of concentrating on mass, it optimized structure. This strategy delivered clear advantages. With its extraordinary length, Supersaurus could access food across an immense area without moving much at all. Simply by extending its neck, turning its body, or taking a few slow steps, it could strip the surrounding vegetation clean. Yet even bodies stretched to such almost unbelievable lengths were not the strangest stories dinosaur history has to offer. The largest creatures to ever live on Earth that we have discussed so far all share one thing in common. They were herbivores. Slow-moving, enduring, and ruling their world, not through speed or aggression, but through absolute size. But in any ecosystem, no matter how vast, predators always exist. The question is this: was there ever a predator large enough to enter the world of these giants? A carnivore of sufficient size to make even the enormous long-necked dinosaurs remain alert? The answer is yes. Prehistoric history has left us two names that represent the pinnacle of gigantism among predators. Measured by length, Spinosaurus may have been the largest carnivorous dinosaur ever to live. Spinosaurus lived around 100 million years ago in North Africa, within vast river and swamp ecosystems. Unlike the familiar image of land-based predators, Spinosaurus was a semi-aquatic creature. The appearance of Spinosaurus is immediately disorienting because it is so unusual. Combining traits of Tyrannosaurus rex, crocodiles, and whales, this dinosaur was also adapted to life in water, hunting even sharks. Its skull was long and narrow, resembling a crocodile's snout, lined with conical teeth that were not razor-sharp but rounded and strong. These were not teeth for tearing apart massive prey on land, but perfect tools for gripping and holding large, slippery fish. The neck of Spinosaurus was long yet powerful, allowing it to plunge its head into the water and wrench prey violently from the river. Its body was not as bulky as that of Giganotosaurus or Tyrannosaurus, but more elongated and flexible. Spinosaurus is the first known terrestrial dinosaur to have adapted to an aquatic lifestyle. Weighing around 20 tons and standing nearly 49 feet tall, it was about 10 feet longer than the largest Tyrannosaurus ever discovered. And then there was its unmistakable feature, the enormous dorsal sail. Towering spines rose from its backbone to form a sail-like structure, potentially taller than an adult human. Some researchers suggest this structure helped regulate body temperature, while others argue it was a display feature meant to intimidate rivals. The exact function remains debated, but visually it made Spinosaurus appear far taller and more fearsome than its actual body mass would suggest. The hind limbs of Spinosaurus were shorter than those of other carnivorous dinosaurs, while the forelimbs were long and powerful, equipped with large claws. This indicates it was not built for fast running on land, but for hunting in and around water. In terms of weight, Spinosaurus was far lighter than the gigantic Titanosaurs. It could not, and likely never needed to, confront fully grown giants head-on. But for juveniles, weakened individuals, or the injured, Spinosaurus could certainly pose a serious threat. In the world of Spinosaurus, gigantism did not come from absolute strength, but from occupying a unique domain where few other predators could compete. If Spinosaurus was the lord of rivers and wetlands, then Giganotosaurus was the embodiment of power on land. Giganotosaurus lived around 98 million years ago in South America, alongside many gigantic, long-necked dinosaurs. When its first fossils were discovered in Argentina during the 1990s, scientists quickly realized this was no ordinary carnivore. Its name, Giganotosaurus, means giant southern lizard. It was among the largest carnivorous dinosaurs ever known, with a length that may have exceeded that of Tyrannosaurus rex. The appearance of Giganotosaurus clearly reflects its ecological role as a high-speed predator. Its body was long, lean, and well-balanced, very different from the heavy build and massive forequarters of T-Rex. The hind limbs were strong and elongated, allowing it to move faster than its size might suggest. The skull of Giganotosaurus was long and narrow, exceeding 5.2 feet in length, armed with dozens of sharp, thin, blade-like teeth. These teeth were not designed to deliver the crushing bite force of Tyrannosaurus rex, but instead were long, razor-edged, and capable of inflicting deep wounds that caused severe blood loss. The structure of its hind limbs shows that this dinosaur was far more mobile than the slow monster image often portrayed in films. Long thighs, powerful muscles, and strong three-toed feet allowed Giganotosaurus to maintain high speed in short pursuits, enough to close in on massive but slower prey, such as juvenile Argentinosaurus or isolated sauropods separated from the herd. One of the most compelling hypotheses about the danger posed by Giganotosaurus is its potential ability to hunt in groups. Based on fossil discoveries of closely related theropods found together, many paleontologists believe that Giganotosaurus may have coordinated attacks, much like large predatory mammals today. If this was true, then even the largest creatures ever to live on Earth were not entirely safe from them. The true danger of Giganotosaurus lay not only in its size or biological weapons, but in its position within the ecosystem. It stood at the top of the food chain in ancient South America, coexisting with the largest herbivorous dinosaurs ever known. In a world where prey continued to grow ever larger, predators were forced to evolve to keep pace. This is precisely what made Giganotosaurus one of the most fearsome predators to have ever existed. It is clear that Earth once allowed life to reach sizes that today are almost impossible to imagine. These giant dinosaurs were not products of chance, but the result of millions of years of evolution under extraordinary conditions. A warm climate, high oxygen levels, abundant vegetation, and the absence of many biological constraints faced by the modern world. Today, those giants are gone, but their traces remain buried deep within the earth, waiting to be discovered and retold. And perhaps the most important question is not which species was the largest, but this. If Earth were once again to experience conditions like those of hundreds of millions of years ago, would gigantism return? And you? What do you think about this question? Which giant dinosaur impressed you the most? Leave a comment below and let us know. Thank you for watching all the way to the end of this video. Do not forget to like the video and subscribe to our channel so you do not miss more fascinating stories from the ancient world. Goodbye, and see you again.